Differentiability of a function. So now differentiability at a point, I'll explain. Now differentiability at a point. Let's say we are discussing differentiability of f at x equal to a. So let's take function like this. Okay. Now you just look at this. Let's say I'm just consider a curve like this. This is x, this is y. This is a function y equal to f of x. Now let us take some point a here. You look at this, the what I am explaining now. Please pay very careful attention. You will understand differentiability beyond a doubt when I explain at this point. So now this is x equal to a. What is the function value here? F of a. This is f of x, right? F of a. So let us say this point we mark as a. What will be the coordinates of a? It will be a comma f of a. What I do next, I take a point to the right of a at a distance of small h from a, and I will take another point to the left of a at a distance of small h from a. So these two distances are equal. Now this point, let it be b, and this point, let it be c. Okay. So what will be the coordinates of b? A plus h, comma, f of a plus h. What will be the coordinates of c? A minus h, comma, f of a minus h. Now, what I do, I'll draw a line such that it passes through AB, and I'm extending this chord. Okay. This is chord AB, and I'm extending the chord. It becomes a secant. This is called as the secant. All right. Now, AC also I join. I'll get another chord. Now, just look at this. What is slope of secant AB? AB. So what is slope of AB? Line joining Maybe secant is an extended chord. All right, we know that. So slope of the line joining these 2 points A and B is f of a plus h minus f of a by a plus h minus a, which will be h. What is slope of secant AC? Slope of secant AC, A and C. So we get f of a minus h minus f of a by a minus h minus a, that will be minus h. So now what I do, I make h tend to 0. Now as h tends to 0, h is a positive quantity. All right, remember h is a positive quantity because we took a plus h and a minus h. So h will be a positive quantity. Now as h tends to 0, the point B moves towards A. You see here? This point B moves towards A here. This is A, this is C, this is B. Okay. Now as B moves towards A, what happens? This AB touches, AB line just touches the curve at A. Then the secant AB becomes a tangent at A. All right. Also, as h tends to 0, the point C moves towards A similarly, right? As h becomes 0, A minus h comes closer to h, closer to A. So this point C moves towards A. In that case, the secant AC becomes tangent at A. All right. Now, this limit of this slope of the secant AB, limit h tending to 0, the slope of secant AB that is limit h tending to 0, f of a plus h minus f of a by h. This is called as, this is written as f dash a plus, and this is called as the right hand derivative at A. Okay, and it is equal to the slope of the tangent at A, considering the secant to the right of A. All right, the way I explain to the students is like this. So I'll draw a tangent line more carefully. So this is the tangent at A. Okay, so the curve this particular line touches the curve at A at one point. So now when you look at the secant AB as h tends to 0, this AB should merge with this line. All right. And the secant AC, this also should merge with this line. All right. If that happens, so if you get a tangent by taking A and a point just to the right of A and draw a line, you get slope of the tangent at A taken from the right, and it is called as the right hand derivative. And if you take limit of the slope of secant AC, which is limit h tending to 0, f of A minus h minus f of A upon minus h is equal to, this is f dash of A minus, this is called as the left hand derivative at A. Now, if this left hand derivative and the right hand derivative are equal, that means both these limits are equal at x equal to A, then we say that f is differentiable. F is differentiable at x equal to A. So the fundamental definition of derivative is also linked with limits only. We have to understand that. That's why concept of limits is the most fundamental and basic. So function is said to be differentiable when left hand limit is equal to the right hand limit. Now of what? The slopes of the secants. So left hand derivative is equal to the right hand derivative. Now, and the limit value is denoted as f dash A, which is same as f dash of A plus will be same as f dash of A minus. Okay, this f dash of A, or we write as dy by dx at x equal to A, is called as the derivative. It's called as the derivative or differential coefficient of f at A, at x equal to A. All right. So this is the fundamental concept. If you look at this way, then you will never go wrong with the calculations of derivatives and functions, derivatives and differentiability at a point. So geometrical meaning. So suppose a function has a smooth curve at x equal to A. Okay, smooth curve at x equal to A. Then you will have a unique tangent. So unique tangent exists at x equal to A. All right. Therefore, f is differentiable at x equal to a. In contrast, let's say we have a function like this. There's also a function. It has a sharp corner. This is at x equal to a sharp corner or sharp edge. Sharp corner or sharp edge at x equal to a. All right. So function has a sharp corner or sharp edge. Now, there is no unique tangent. Why? Because you take at a, you take a point just left to a and draw a line. So that tangent will be like this. This will be one tangent to the left. Then take the point A and just to the right of A, you take another point and you draw a tangent. It will be like this. Tangent at A plus. This is tangent at A minus. Okay. The sharp corner or edge. So whenever there are sharp corners or abrupt change in slope, then the function will not be differentiable. Function will not be differentiable at x equal to a. Whenever there are sharp corners, abrupt change in slope. Clear? So geometrically, this is the meaning of differentiability. If function is differentiable, there will be a smooth change in the slope. The curve will have smooth curvature. Whereas if there is a sharp corner, then there will not be a unique tangent, which means function is not differentiable. Right hand derivative will be slope of this tangent and left hand derivative will be slope of this tangent. Okay. Is it clear? Everyone, please respond.
Yes, sir.
Okay. So this is the geometrical meaning of derivatives. And if a function is differentiable, so if a function is differentiable, at x equal to a, then the slope of the tangent at x equal to a is called as the derivative of the function at x equal to a. Slope, derivative of a function is nothing but the slope of the tangent at that point. This we will use so much in application of derivatives. This concept is so important in application of derivatives. All right. So this is about differentiability. I hope it is absolutely clear.